Hey everyone, today's lesson is Chapter 9, Section 1, Day 1. We're going to be learning how to graph on the polar coordinate system. And so if you're accompanying this video, you may want to go ahead and print out the polar coordinate worksheet that I put on the Blackboard website. You'll need this type of polar grid in order to graph polar coordinates. When we're talking about polar coordinates, they're different than the ones we're used to. We're used to what's called a rectangular coordinate system. And the rectangular coordinate system, we learned about that in Algebra 1 and maybe even pre-algebra, where we were given an x-coordinate and a y-coordinate. And those two numbers let us know where to go left to right, which would be on our x-axis, and vertically, which would be on our y-axis. And so one coordinate could tell us how far left and right to go with x and how far up and down to go with y. And we could say, okay, here was a point on the coordinate grid. This many x's, comma, this many y's. Well, polar coordinates work a little bit different. In polar, we don't talk about x and y's, we talk about r and theta. R stands for the radius, or the distance from the pole. The pole that we call in polar graphs is the center or the origin, as we're used to in the rectangular plane. And the r describes how far away from the pole we go. Or, as you see with all these circles here, it also measures the radius. Okay, theta describes our angle of rotation. Okay, so once we go out along the radial axis, that's this axis right here, the radial axis, we can then look at theta and determine how far around the pole to rotate. Okay, so let's go ahead and label our axis. If I was to label the radial axis, every time you see a new circle here, that would be 1 unit further along the radius. So the radiuses get larger and larger as we go further out. This circle here goes all the way out to a radius of 8. We do have negative coordinates. If we go to the negative side of the radial axis, this would be -1 radius, -2, -3, -4, and all the way back out to -8 as well. So our radius not only tells us how far away from the pole to go, but which side to go from. So if we have a positive radius, we would start on this side of the radial axis. If we have a negative radius, we would start on this side of the radial axis. Okay. Now our angle of rotation, if we have a positive angle of rotation, we would start here and move clockwise, or sorry, counterclockwise. A positive theta moves clockwise. Okay, a negative theta goes in the other direction, counterclockwise. I'm sorry, said that completely wrong. A positive theta is counterclockwise, and a negative theta is clockwise. As you can tell, it's very easy to get these mixed up, so make sure you're thoroughly thinking about which direction to go depending on whether or not your theta is positive or negative. Okay, so if we were to figure out what each of these spokes is radially around the pole, first thing we'd want to do is say, okay, this is definitely going to be 90 degrees, and if I count each of these spokes, as we call them, there are 1, 2, 3, 4, 5, 6 spokes in each quadrant. So that means each of the spokes, if I divide 90 by 6, is going to be 15 degrees. 15, 30, 45, 60, 75, 90. And we could keep going too. If we were to continue in the positive direction, this would be 15 more degrees would be 105, 120, 135, 150, 165, and then 180. And we continue all the way around to positive 360. We could, though, go in the negative direction if we wanted to, and call this direction negative 15 degrees, negative 30, negative 45, negative 60, negative 75, negative 90, negative 105, negative 120, negative 135, negative 150, negative 165, and then negative 180. Okay? And so you'll probably realize that several of the spokes then get two different types of angles on them, right? Because if I go in the positive direction, this becomes positive 180, or if I went in the negative direction, this would also be negative 180. And so we get duplicate angles as we go around. And we're going to talk about the different ways we can write polar coordinates in our third example. Okay, so let's go ahead and practice plotting some of these now. For our first example, they want us to just graph the points and label them A, B, and C. And really, when you're plotting a point, that's all you have to do. And you can combine these on one example. So for problem A, we want to go to the coordinate 2, 45 degrees. So since my radius is positive, I start at the pole and I go on the positive side, 1, 2. That means I'm going to be on this second ring, and I'm going to start on the positive side before I do my rotation. It's important to know where to start before you begin rotating. So since I know I'm starting here on the positive side, and I'm going to rotate a positive 45 degrees, that means to go counterclockwise. So each spoke is 15 degrees, just like our last one. This would be 15, 30, 45, stopping right there. Okay, it may help on the first few ones to go ahead and draw this arrow to show where you're rotating from, so you can double back and check. Okay, yes, I went positive 2, and then positive 45 degrees. That's counterclockwise. For example B, now they've changed the radius. The radius is negative. So we're going to go on the negative side of our radial axis. This is negative 1.5. I'm in between, exactly halfway between the first ring and the second ring. And I'm still rotating positively. So I still need to go in the same direction. Just like we went positive 45 degrees up here, I need to go positive 2 pi over 3 radians. If you're not sure how far that is, you can convert it into degrees by multiplying by 180 over pi. When you simplify that, you'd see this is 120 degrees. So if I count my spokes, this is 15, 30, 45, 60, 75, 90, 105, 120. Right here is point B. And again, if you want to, you can draw your arrow of rotation just so you can double back and check. Oh yes, I rotated correctly. And then for our last point, it's 3, negative 30. So I start at the pole. I go out 3 units positively, 1, 2, 3. And then negative 30 degrees, so that's in the clockwise direction. This is negative 15, negative 30 right here. That would be C. Okay. So I'll give you 3 points to try on your own. D, E, and F, you can actually graph them on the same graph we just did our first example on. Okay, if you want to check your answers, here's where D, E, and F should locate. I didn't draw the arrows in when I worked it out, but I'll go ahead and add those in now. If you went in the right direction here, this would be counterclockwise because it was positive 90 degrees. E was 240 degrees. So we're going all the way around the circle. We would be starting here and going all the way around 240 degrees in the positive direction. And then this last one, we went in the negative direction. So F started here out at 4 and then went clockwise around to this location. Okay. Here are a few more examples you can do for practice. Okay, if you plotted those correctly, this would be your location for P and for Q. Okay, the last thing we're going to do before we finish off this section is practice renaming a single coordinate 4 different ways. Technically, there are 4 ways we can approach this coordinate on the polar grid. We can approach it from the positive radial axis and from the negative radial axis, and we can both approach it in positive angular direction or negative angular direction. So there's a couple different ways you can think of it. If you don't want to have to graph it and look at the graph each time, I can show you how to do that, but if you have the accessibility of a graph, it's pretty easy if you just plot it and then just look at all the different ways you can reach it. The first thing I would do is if I was given T, I would see the positive radius that I could use in the positive rotation. That's the least likely one to screw up. So if I look here, T is on the 4th ring out, so that means I have a radius of 4. So that's my first coordinate. And if I count how many spokes it goes around, they've labeled them nicely for us here. It's on the spoke for 135 degrees in the positive direction. So that would be coordinate T. Now, if I want to figure out what would be the coordinate if I went in the negative angular direction, we could go counting in the negative direction, but an easier way would just be to subtract 360. If I subtract 360 degrees, I get a coterminal angle. It'll still be within my range. And then this new coordinate still has a positive 4 radius, but now the angle is going to be negative 225. So different coordinates, but the same point. The other two pairs of polar coordinates that we're going to find, we're going to have to take the radius and start it on the opposite side. So we're going to start at -4 on the negative side of my radial axis, and then rotate accordingly. So I'm technically starting here. Now if you have the graph, you can just count backwards and see, okay, if I go clockwise 45 degrees, that would put me at t. But if you don't want to do that, you also could notice that the pattern is if you change the side that you're starting on, you have to add or subtract 180 degrees. So if I wanted to, I could just say, oh, let me just add 180 degrees to this, and -225 plus 180, well, that's -45 degrees. And we can confirm that by looking at the graph. If we start here and go negatively 45 degrees, that's 15, 30, 45 degrees up to t. The other one, now that we have all three of them, the last one we can just take the negative radial axis and then find the coterminal angle with -45 degrees. So instead of thinking of it as going -45, I can go positive 315, and we get that by adding 360 to -45. So that's how you get positive 315 degrees for your last coordinate. And so all four coordinates give you the same exact point on the graph. Okay. For the last set of problems, try these two on your own. If you want to check your answers, these would be all of the coordinates that would match them. Make sure if they give you your problem in radians that you give your answer in radians. So if you have to convert it to degrees because you're not good with fractions, make sure you convert them back into radians. It might take a little more time, but that's how the choices are going to be on the multiple choice test. Okay, that's it for this lesson. Make sure that you do the classwork that goes with this, or the homework I should say. You're doing examples 1 through 12 and 14 through 21. You can graph all these points on the same coordinate grid. You don't have to do a separate grid for each point. And this you don't really need the grids for at all.